Indirect proof of inequalities in one triangle. We're talking one triangle today, kids. Central question today. How are the sides related to the angles of a triangle? Okay, how do we talk about sides as we relate them to angles? How are any two sides of a triangle related to the third side too? We're going to talk about that. So, volunteer for goals today. Who wants that? Thanks, Michael.
Write indirect proofs, list sides and angles of a triangle in order by size. Use the triangle inequality theorem to find possible side lengths of triangles.
Right. So, we've written a lot of proofs before. We're going to talk about writing indirect proofs. And in the vocabulary down there, an indirect proof is stated as start by making a temporary what? Assumption that the desired conclusion is false. By then showing that this assumption leads to a logical impossibility, you can prove that. So we're actually trying to do, the word really here is contradict a statement. We're trying to show that something is false. Okay? If it says prove it, I don't know. I mean, I would say maybe everybody in this class is a boy.
Well, you can't argue that.
Well, probably picked the wrong subject, but let's not take it out of context right now. But an argument would be, well, I'm going to prove that that's not true because Audrey is a girl. Right? Right?
Are you?
All right.
I think.
Well, I didn't have Natalie in this spot.
So we'll look at an indirect proof here in a little bit. But we're trying to show that stuff is true by, prove the original statement true by what? Okay. I'll show you what that means in a little bit. Guys, we've talked about proofs before. We have two-column proofs. They're just arguments. They're logical arguments. We've talked about that. I don't need to spend time on that. Inequalities is a formal statement of inequality between two quantities using signs of inequality such as less than, greater than. If I put two numbers up here, 12, 16, what inequality signs could I put in there to validate that? 12 is less than 16. Is that the only one that would work? Less than or equal to. It's less than still. Okay. So you know what inequalities are. You know what proofs are. Indirect proof will be a new one for us today. Okay. Not going to spend a lot of time reading that because you guys should know most of that right there. Okay. All right. Let's get moving to page 2, kids. This, like I said, not going to take terribly long today. Okay. Writing an indirect proof in example 1. Okay, how about a volunteer to read what we need to do in example 1? Okay, Michael, go ahead.
Relating side length and angle measure. Write an indirect proof given line L is not parallel to line K. Prove angle 3 and angle 5 are not supplementary.
Okay. What's given up here?
Line L is not parallel to line K.
Do line L and line K look parallel?
Yeah.
Sure.
But they're not.
But they're not. There's no label up there that says they're not. And they're telling you they're not parallel. Right? It says that prove angle 3 and angle 5 are what? Okay. Well, here's the deal. Instead of saying the lines are not parallel, let's assume that they are parallel. Okay? If the lines were parallel, then angle 3 and angle 5, anybody remember what you call angle 3 and angle 5 when they're on the same side of a transversal and they're on the interior?
Corresponding interior.
Not corresponding interior, they're called, it starts with a C, one right after the other.
Corresponding.
Convex.
Consecutive interior.
Consecutive, one right after the other, okay? So here's what I can say.
Boom.
I can write down here, kids, by converse, I'm going to say this. If L was parallel to K, then, I'm going to write it this way, then by the converse of the consecutive Are these interior angles or exterior angles? Consecutive interiors angles theorem. If L was parallel to K, then by the converse of the consecutive interior angles theorem, angle 3 and angle 5 would have to add up to how many degrees? Angle 3 plus angle 5 would equal 180 degrees, meaning supplementary, right? But what's going on here, kids? We're assuming L is parallel to K, but that is not the case. Because L is what? Okay. I'm going to write however. L is not parallel. If I make a parallel sign like this and draw a line through it, are you okay with that? Yeah. L is not parallel to what, K? Or, I'm sorry, L is not parallel to what? Because that's given to you, right? However, L is not parallel to K, therefore, what can I say? Angle 3 and angle 5 would not add up to 180, therefore angle 3 and angle 5 would not be what? So I'm going to say angle 3 plus angle 5 would not equal how many degrees? Would not equal 180. So they are what? So angle 3 and angle 5 are not supplementary here. Okay, so indirect proof. Let's think about this. Indirect proof. They gave you right off the bat that L was parallel to K or not parallel to K in the given information.
Not parallel.
We took the given information and we assumed just the opposite of it. And we said, well, if the opposite was happening, this is what would happen. But since the opposite is not happening, then what we just said cannot happen. Does that make sense?
Yeah, this is fun.
But it wasn't
Okay.
really a, it was a paragraph proof.
Pretty much it is a paragraph proof. Indirect proofs mostly are paragraph proofs. Okay. So just put your thinking down there, and we'll end it with a period. Okay. And honestly, most of the examples you see right there, again, what's given right here, try to start by contradicting it first. Okay. So maybe start by talking about the opposite and say, well, if the opposite was true, then this would be true. So since we're not dealing with the opposite, then what we just said cannot be true. So we've contradicted it there. Okay? Contradicting. All right, so you're going to see some stuff like that. And that's not the part that we're really focused on today. What I am worried about today then is this, kids. Example 2 is where things get really pretty cool. We're still dealing with what kind of shapes here, for the most part, in our chapter. Triangles, okay? This is where I think things get really important for you. And honestly, I'm going to be honest with you. If you can count, if you can order numbers, you're going to be just fine today. Just fine. But I get it, that counting thing gets screwed up. Every time I try to count my money, I always feel like I have the wrong number. Not enough.
Then you get it.
Okay? All right? Okay, how about a volunteer to read what we're doing in example 2 when we were talking about relating side length and angle measure? Go ahead there, Michael.
Draw the following triangles. Find the largest angle and the longest side and mark them in red.
Okay.
Find the smallest angle and shortest side and mark them in blue. What do you know?
Okay, so I'm going to draw, first of all, what kind of a triangle? I'm going to do my best to draw an equilateral triangle, okay? What's true about all sides of an equilateral triangle?
They're equal.
They're all the same, okay? So take a second and sketch that. It doesn't need to be perfect. And maybe what you want to do is put a tick mark through them to say, oh, all 3 of those sides are equal.
And the angle
What are the angle measures in an equilateral?
60.
Okay, so I'm going to draw this. 60, 60 degrees, 60 degrees. Okay, let's draw another one. Another one is what? Obtuse. Let me see if I can do this. Okay, what's true about two sides in an obtuse isosceles?
Same.
Two sides are
Equal.
equal. Okay? And then let's draw an obtuse scalene triangle, meaning one angle's bigger than 90 degrees, but all three sides are okay. For our purposes, I'm going to put some angle measures in up here. I'm going to say that this is about 120 degrees, which would make that middle one would be about 30 degrees down here and 30 degrees over here. Okay. And for our triangle over here, I'm going to say that our obtuse angle is 110 degrees. I'm going to say that this side is, how about 30 degrees up here at the top, and over here 40 degrees. Okay. Does everything add up to 180 there in each of those? Everything add up to 180 in each of those?
Yeah, it does.
I think we're
What
okay.
is the, is that 120?
Yeah, let me clean that up a little bit. Is that better? Okay, here's what we're after today, kids, and this is kind of what I want you to explore or understand. What's true about all three of these sides here, kids?
They're all equal.
They're all equal, okay? What do you notice about the angles as well?
They're all equal as well.
Okay. So what I'm going to tell you is this, and this is how I'm going to highlight this. When I highlight stuff right here, this angle, I don't want that color. I want to highlight it. This angle right here is kind of opposite of this whole side right here. Okay, that angle is kind of opposite that whole side. So when I have an angle, 60 degrees in this case, and a side that's opposite, if all the angles are the same down here, so for this particular angle right in here, what should be true about the side that was on the right highlighted compared to this side? They're the same. Now think about it. Look at this triangle over here. If this is 30 degrees and this is 30 degrees, what's true about this side and this side? Are both of those sides across or opposite the 30-degree angle? In other words, my 30-degree angle right here is opposite that side right there, right? So if my two 30-degree angles are here and here, aren't the opposite sides the same length? So my question becomes then this. I'm going to put side 1, side 2, side 3. Which side, 1, 2, or 3, is the longest side there?
1,
Okay. What's the second longest side?
2,
What's the shortest side? Okay. Notice this right here. Side 1 is the longest side, and side 1 is opposite which angle?
The biggest.
The longest side will always be opposite the biggest angle, okay? The second longest side will always be opposite the, okay, is 40 bigger than 30? So if 40 is bigger than 30, that means side 2 must be longer than side what? 3. Guys get that concept? Okay, so let's take a look at this on the next page. There's two theorems here that we're going to talk about. One's a triangle, longer side theorem. Volunteer to read that for me, please. By default, Michael, it's you.
If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side.
Okay, let's draw a triangle here.
What?
That was a lot of opposites.
Here's my triangle. I'm going to label my angles A, B, and C in here. I'm going to tell you that the distance here is 20. This is 12. And this is 28. Okay? 12, 20, 28. Longer side theorem. If one side of a triangle is longer than another side, then the angle opposite is larger than the other. My question to you is this. Put your angle measures in order from least to greatest. What's the smallest angle up there? Why is C the smallest angle?
Because it's opposite.
Because it's opposite the shortest side, 12 right here. So up here, this really means C. That angle C is going to be less than angle what? What's the second smallest angle? Or the next one in line? A. Because A is opposite of what?
Second smallest side. 20.
And what's the last angle then? Okay. C has to be the smallest angle. A is the middle angle. And B would be the largest angle. Okay. Now, the opposite of that is true as well. If I have the larger angle theorem in a triangle, larger angle theorem, or triangle larger angle theorem, if I do this, let's just draw another triangle. How about like this? Okay? I'm going to go ahead and say, this is 90 degrees, kids. This is
45.
40 degrees, kids.
What?
This is 50 degrees.
Oh.
I'm going to label my side A, B, and C here, like so. You take a second and draw that diagram.
I thought all right that can't be right, because all right angles are 45 and 45, right?
No.
What?
What's 40 and 50 add up to?
180, but would that not make sense? I thought all...
You're thinking of half of the square. What about this triangle? You're
Yeah,
thinking
but
half.
You can't have like...
This is a 90-degree angle, right? You're overthinking this. I can have that. That's a possibility.
I thought that's what all...
I might also have a right triangle that's like this.
Oh, okay.
Okay. Got it now?
Yeah.
Okay.
Yeah.
I'm just thinking, you know, like, I thought all 90 angles were 45.
If you bisect it, it's 45. All right. What's the largest side here, kids? What would be the longest side? The way it's diagrammed, what's the longest side? A has to be, because it's opposite the biggest angle. So let's put this in order from least to greatest. What's the smallest angle, kids?
40.
Well, 40 is the smallest angle, so go across from 40. Where are you at? So side B has to be less than, okay, what's the next side in order? 40, 50, 90 would be the order in here. So we would go opposite 40 first, opposite of 50 second, which would be what? So side B is less than C, but those are both smaller than what other side?
Hey.
A. Why is A the largest side again, kids?
It's opposite times.
It's opposite of 90 degrees. Oh my gosh.
Oh,
Nice move.
Pull something.
pull something, just do a nice.
I wonder if I can get unemployment now. Go home, lay in bed, and get paid.
Yeah, we all witnessed it.
Yeah.
Huh?
60%
I want 100%.
120.
Keegan, I have to put up with you. I should get 120%.
Yeah.
Get 130.
Let's see.
Can you get unemployment with the government shutdown?
I can, because we're open right now.
This is state.
Some of the people that are shut down can't. You know, I don't, the whole thing's done.
Yeah.
You know,
They can't use like.
I heard that there's a conspiracy anyway.
I think they're trying to.
You heard that when the Kool-Aid man, you heard about the Kool-Aid man? When he yells, "Oh yeah," and runs through the wall? I guess that he's hanging out down in Mexico right now. The Kool-Aid man's gonna run through his wall.
Oh god.
That's funny. I'm gonna dress up in school.
That'd be funny. Oh yeah. All right, here we go. Listen up, kids. List the angles A, B, C in order from smallest to largest. What's the smallest angle here, kids? You guys do this on your own.
A.
Why A?
Because it's a...
Opposite the shortest side is A. 11 is the shortest side, so opposite of that is A. So A is the smallest, which has to be less than what next? B, which is less than what?
Well, that's weird.
That's pretty easy, isn't it?
A, B, C.
Now don't lose sight of this, kids. How many total degrees are there in a triangle? How many degrees? What do the interiors add up to? 180. So, gosh, could I figure out angle C if you know two angles?
Yes.
How many degrees is it? Okay, you guys on your own, go. It says list the sides of BC in order, or triangle ABC in order. What has to be the shortest side?
B. BC.
B to C. So side BC. What's the middle side?
Yeah, BA.
Okay.
AB.
Which is less than, what's the last side then, kids? Yep.
AC.
AC or CA. Doesn't make any difference. Okay? Do you guys get this?
This is
Pretty simple, right? Okay? Now they're going to throw a lot of words at you in this next page, or this final page here, okay? They're going to throw a lot of words at you. It's going to be kind of confusing, but I think diagram-wise will make this understandable. Did everybody have that previous page? Are we good here? All good? All right. So let's roll here. So this is an important one. This is called the triangle inequality theorem, kids. And here's the deal.
There, I got it. Using this.
I don't know how to explain this. All right, come here, kids. Let's do this. Come up here by Audrey's table for me. Okay. I've got some edges of things right here. Okay.
Cock-a-doodle-doo.
Now I'm going to start with these. Okay. Here's my situation. Are you ready, kids?
No.
Okay. I'm going to start with these three things right here. I have an edge here, I have an edge of this paper, and I have an edge of this. Okay? Make sense to everybody? Make a triangle with those three edges. Go. No, you got to go corner to corner. You can't. You got to go like this, yeah, or maybe even this. Okay.
Yeah, it's like fun.
Make a triangle. Is it possible?
Impossible. What?
I just. Oh.
Those are your tools now. Make a triangle.
It's gonna be possible. Does this corner have to meet up with this?
Does it have to go corner to corner?
Yes.
I think it would be. Oh gosh.
That's a triangle.
Okay, so that's pretty good.
But it will become
Okay.
impossible eventually.
Now, why might it become impossible?
Because you can't do it on this side. So
Well,
you can't do it on
could
this
you
side.
have done it on this side?
That can't be better.
Oh, I guess.
You
really gotta go down.
Really.
Yeah.
Okay, it was possible here, right?
It just doesn't look very triangle-y, but it still is.
But it is a triangle, right? So that would have worked.
It'll get infinitely close, so you can always do it. Except you can't. No. Sorry.
Could it work on this side?
Wish I had a catheter.
Impossible.
I don't think it's working, is it?
You need bigger.
Now, wait a second.
You need a bigger
We're a
thing.
little, okay. So here's the deal. What you're saying here is these two sides have to be something to come together, but they have to add up to be longer than
The longest side.
the longest side. So here's the deal. Anytime you have two sides of a triangle, the two sides, the two shorter sides, or any two sides that you pick, I don't care which two sides you pick, whatever length this is and whatever length that is, they have to add up and be more than the.
But isn't it a squared plus b squared equals c squared?
It is, but we're not dealing with just right triangles anymore, because that's only relevant to right triangles.
Okay.
Okay? So what we're saying is this: I have to have it if I pick two sides. These two sides have to add up to be more than. That's it. Because think about it. What's the shortest distance between 2 points?
The straight.
It's a straight line. Okay, so that means that if I had a triangle right here, like this one, let's just pretend the edges are routes right here. You get from this point to this point, a straight line would be shortest, but if I took this route right here, that would have to be more than that distance, right? Okay, so here's what that's saying right. You guys can head back to your seats. What this is saying is this. It says the sum of the lengths of any two sides of a triangle is greater than the what? I'm just going to do this. I'm just going to draw a triangle. You draw a triangle like this. I don't care what it looks like. Kind of like that. I'm going to label my sides A, B, and C. Okay? What this is saying is the following. This is simply saying, if I take A plus B and add A plus B up, obviously what's the longest side in this triangle? But if I take A plus B, it has to be more than what? What if I didn't do that? What if I took A and C? Sides A and C added up would have to be more than what? What if I said, you know what, I don't want A at all. I want to take B plus C. What's that have to be more than? Okay? So let's look at an example here.
If you add any two of them up, they have to be bigger than the
Any two sides in a given triangle, added up, two sides, I don't care what you pick, they have to be more than the...
third side.
Yep. So it says in a triangle, one side has length, what?
6.
And the other has length.
15.
So let's just say that this here is 6 right here, and this is 15 right here. Okay? So what this is saying is this, kids. I don't know what this third side is.
But it has to be first.
So let's talk about this. I know right here from the following, kids, that 6 plus 15 has to be greater than what? Side C. Okay? What is 6 plus 15?
That'd be like 21.
So from this right here, I know from this mess right, whoops, I didn't want to do that.
21 is greater than C.
Why did it do that?
It's okay.
That looks weird.
I like it.
Okay, so from this, I know that 21's bigger than what? Gosh, dang son of a gun. 21 has to be greater than what? So that means C has to be smaller than what value? Okay, C can't go over 21. You're saying this length C, if it was 22, would this work? What's 6 plus 15 again? 21. 21 has to be bigger than the third side, so if this is 22, would it work? No. Hey, here's another one, kids. I also know that one of these sides right here, like say maybe 6 plus what? 6 plus C would have to be greater than what? So let's write that. I would also know that 6 plus C has to be greater than 15, which means C has to be greater than what? If I subtract 6 from both sides, C would have to be greater than what? Okay? So I need at least 9 to get to that 15, but I know I can't have anything over the sum of these of 21. Listen to what I say here, kids.
I know it now.
What is 6 plus 15?
21?
What's the big number 15 minus 6?
11.
9. What this is saying is
Biggest
this.
number in this one.
Yeah, what this is really saying
Right,
is
okay.
your C value can be anything between 9 and 21. Okay, your two sides are 6 and 15. Think about it. So think big and small. Take 15 plus 6. What is that?
21.
21. Take 15 minus 6. What is that?
9.
That is simply saying that you have to have a length somewhere between 9 and 21. Okay? It can't be equal to 9, because if it's equal to 9, it will just be a flat line. Okay? Has to be between somewhere between 9 and 21. So listen to what I say, kids. I'm going to write this down. C is between 9 and what? Well, 21. Or you might see it written as 9 is less than C is less than 21, like so. Okay? All right, hear what I say. Two sides of a triangle, you ready? 23 and 7. 23 and 7. Two sides of a triangle are 23 and 7. Third side, tell me what it has to be between.
Between 30 and 26.
Nope. I like 30.
16.
Okay, 23 plus 7 is 30, right? So I can't go over 30. What's 23 minus 7?
16.
So the length of that third side has to be somewhere between 16 and what? 30. Okay. 10 and 4. What are your lengths? Between 6 and 14. You've got it. Okay, you've got it. All right, kids, here's what we need to do then. Let me stop this here quickly.